giving you about. I will give your introduction and then you can start.
Okay.
So, a very good morning, everyone. Today we have Mr. Jamit Gandhi from Vice TV Electronics India Private Limited. He is working as a software developer. He will give a brief about how television industry works on recorded episodes as well as video streams. And uh, thank you, Jamit sir, for accepting the invitation. And now you can start, sir.
Okay. Tulsi ma'am, is my pleasure to present now, and I'm giving my brief introduction. Myself, Jamit Gandhi. I am currently working at Vice TV as a software developer. I have done my BTech from DDIT Nadia. Okay. Today my topic will be how video processing works and what its application and how in real time industries like Google Meet, Zoom, or ZTV or any other broadcasting channels works. First, we will start from the how broadcast industry like ZTV, Sony Live, other works. Then we will go to the how Zoom work, how Google Meet works, and how WhatsApp works. Okay. Uh, Now I'm presenting my screen. Okay. Can you see my screen?
Yes, sir.
May,
It is visible.
okay. Okay. Now we will start with our new application. Okay. First, we will start about what is the video. As only 2% of us know that what is the video and how video works. Actually, video is nothing but an image. And what is an image is a collection of the different pixels, like my you can see my screen. Yeah, one pixel here, it's an image. And what is the video is the collection of a picture within a frame. Like what is frame is nothing but image as a raw presentation. Okay. Now we can see in this slide the video is an electronic medium for recording, copying, playback, broadcasting, and displaying of moving visual media. Then, as I said you that video is a frames number of images, collection of images. What is the collection of images in video industry? We called it as a FPS. As you know about the FPS, might heard about it or not. FPS is a frame per second. How many frames are there in a single second that can change immediately? Like our broadcast industry, like ZTV or any other industry, it works on 24 to 25 FPS. That means in 1 second, we are seeing 25 frames or 25 images at a speed that we, a human eye, cannot capture that the images are actually changing. Okay. Now moving towards the how video is represented. The video is represented with the display resolution, aspect ratio, refresh rate, color capabilities, and other qualities. You might heard about the refresh rate. First, I will talk about the refresh rate. In refresh rate, I have one example, like this is the refresh rate you have seen on the YouTube video or at any other style or other slide, or you can also see from the my slide that video like 60 hertz. 60 hertz is what hertz, we know the hertz is what 1 upon t. 1 upon t means 1 upon second. In 1 second we are seeing 60 frames are changing constantly that human eye cannot capture it. Like when for 90 hertz 90 frames are actual changing within a second. As and in 120 it is the same. So we can see the difference that in 60 frames we can see some lagging, in 90 frames some less lagging, and in 120 hertz we are seeing totally no lagging. And currently I have 144 hertz laptop. So on your laptop you might have the 60 hertz, and in other laptops you might have the 90 hertz. This is the refresh rate. Then what is the display resolution? Display resolution is like 1920. We all about the 4K video or HD video or SD video. What is the display resolution? Display resolution is about the how much pixels are there in a single image. In 1920 by 1080 we have 1920 by 1080 matrix. In mathematics we have learned about the matrix. It is the same as same matrix, but it is a 1920 by 1080 by 3 or by 4. What is by 3? By 3 is the RGB image. Now I will show you the what is the RGB image. RGB is the layers in the image. So as you can see, there are three channels in every image. We can represent each and every color within the three colors like red, green, and blue. With the combination of three colors, we can represent any color in this world. So we have the 1920 by 1080 by 3 in a single image to represent one image. Okay, now I talk about the aspect ratio. What is the aspect ratio? Aspect ratio is the nothing but a width by height. 1920 by 1080 is 1920 divided by 1080 is our aspect ratio. What is the color capabilities? Color capabilities are like RGB or YUV or HLS or another color capabilities. Here it is here is the detail about the aspect ratio. Aspect ratio we see in the standard definition. If we purchase our setup box with no HD, then we will get 640 by 480 as a image. Like if we have a ZTV subscription, in ZTV we are not subscribed for the HD channel, then we are getting 640 by 480 pixel size image, and it comes as a video. And aspect ratio will be the 4:3. And now what is the other names for this 640 by 480? We have to look at the height of this, not the width of this. This is 480 means 480 height, 480p. Now what is p? P is a progressive. We will see in the next slide what is progressive. For HD channel, if we have subscribed for HD or full HD channel, then we will get the 1280 by 720 pixel, and its aspect ratio will be 16:9. In our mobile, lots of us have the 16:9 ratio. So, and what the other name we can call is 720p. And in full HD we will get 1920 by 1080. It is also has a aspect ratio of 16:9. I will quickly go through this my slide. Aspect ratio describe the proportional relationship between the width and height. As I said that it is nothing but width upon height and the video picture elements. All popular video formats are rectangular. Rectangular means 1920 by 1080 or 640 by 480. It is not like the 640 by 640. We don't have square TV or square display or any square laptop. So that's why we have rectangular view. And uh, uh, ratio between width and height. The ratio width to height our traditional television screen is 4:3. So in our TV we will see for HD channel we all have SD channel subscription rather than HD or full HD channel subscription. So we will get 4:3 aspect ratio. So we will getting 640 by 480 pixel. High definition television, like we have 4K or 8K video, or if we subscribe for full HD, then we will get 16:9 aspect ratio video. Here is the detailed description about the resolutions and aspect ratio and other names. I will go through. We all see that the standard definition it is SD. Then we have seen the HD high definition. We have also seen the full HD. Now we will go about much deeper than what is the 2K, what is 4K, what is ultra HD. 2K is nothing but 2 times full HD. If we multiply 1920 by 2, then we will get 2048. And to correct the height and width, they have changed some height and width, and I can say they have take some privilege to change some height and width. So it will be like 2048 by 1152, and aspect ratio will be 1:1.77. For ultra HD, ultra HD is nothing but a 4K. We are now moving toward the 4K videos. 4K videos is full time full HD. So 3840 by 2160, which has the aspect ratio of 16:9. Then we have DCI 4K. DCI 4K is nothing but same as the Ultra HD, but it has some higher width. See, we can see the difference. The height is the same, 2160, but width is something more than the full 4K. 4096, which has the aspect ratio of 1 gem 1.9. We all have seen the YouTube videos, like, and we see that sometimes quality may degrade, or sometimes we get the higher quality, and some videos are already recorded at a very high quality. Okay, so very high quality we will get 4K as of now in YouTube. So 4K has the 2160p that we have seen. That we have to look at the height, not the width. 2160p is progressive. This is nothing but same. 2160p 4K. 1440p is near to 2K, not exactly 2K, but near to 2K. Then full HD. We have seen the full HD 1920 by 1080, which has 16 gen 9 aspect ratio. Okay. Likewise 480p. 480p nothing but HD video. For lower quality, we have very less internet connection. Like we have a less than 1 Mbps internet connection. Then we will get 220p, 240p, or 140p, or sometimes we will get 360p. If we have higher bandwidth or a higher internet connection, then we can get up to the 4K resolution, and we all have seen in the YouTube that. Okay, now this is the actual image, how aspect ratio and how the 1920 by 1080 or another height and width are calculated. We have seen that. You can just quickly go through these my lines, like how the camera lens works, and how full HD videos are shooting. Okay, now we have some a very high level idea that uh, what is a video and what is image, and how it is represented, how it is recorded in the recorded by the camera, and how actually we get the 1920 by 1080 or SD or lower SD. So now I'm going to talk about 4K video. Now people are moving towards the 4K, not full HD. Full HD, till now we are using full HD, but people are moving towards the 4K. What is the 4K? 4K means four times full HD, means four into 1920 by 1080 by 3. Yeah. So I'm going to going through my slides. A 4K display is one with at least 8 million active pixel. Now what is the pixel? I have said that we have the matrix. In matrix we have 1920 by 1080 or 640 by 480, and now each 480 640 by 480 image is divided into the small pixels, and with the collection of pixels we have one image, and with the collection of image we have one video. So that is nothing but pixels. For television, that resolution has standardized to 380 by 3840 by 2160. Digital cinema 4K, the resolution in 4K movie theater is slightly higher at 4096 by 2160. In 4K we have 3840 by 2160, but in DCI 4K we have 4096 by 2160. So we are using DCI, digital cinema. However you define it, it's four times the number of pixel on 1080p. As I have said that, and we can calculate that it is over 23 times the resolution of SD. What is SD? SD we have seen that 640 by 480. So in a single image we have 23 times more pixels or more calculations than a simple SD. So you can think in the terms of how to calculate each and every pixel and how to display that. It is becoming more and more complex. So as this is rightly said that 4K is obviously much sharper than the 1080p. In the space that 1080p TV holds a pixel, and a 4K TV of the same side has 4 times. means nothing but 4 times 1080p. Okay, that makes for significant jump in clarity. In 4K video we see the sharp and crisp and clear clarity. Even we can see our hair or beard on our face, like it is very deep. This is a pixel in terms of the height and width. This is VCD. In earlier days, before DVD, we have the VCDs. In VCD, we have very low, less resolution, like 360p or lower than that. Then we have DVD. Then we have 720p. Then we have 1080p. In DCI 2K, we have some more width. Then we have Ultra HD 4K, and then we have DCI 4K. DCI 4K has some more width. Okay, then I have talked about that what is P. P is a progressive. Then also we have alternative, like what is I. I is an interlace. So now we need to understand what is P. Like we have seen on the YouTube that this P, but we don't understand what is P. We don't have any idea about P. So now I am going to talk about what is progressive and what is interlace. In progressive, we have each refresh period updates all scan lines in each frame in sequence. This means what? Suppose I divide my display, my 1920 by 1080 display in 1080 lines. I have 1080 rows. So I have the index starting from 0 to 1079. So I can divide each and every row with an odd and even number. Zero number row, zeroth number row, second number row, fourth number row will come into the even. One number row, third number row, and up to 1079 number row will come into the odd. So we divide each image into the odds and evens. But in interlace part, in interlace, this is the interlace. I am showing the image. Odd numbers row are divided as a other side, and even number rows are divided into the a different side. But in the terms of progressive, we don't divide this into the odd and even. All the image are continuously divided. Like we can see in the here is a we can see that all the rows are divided consecutively, but this is not the case with interlace. So now I hope that you got the idea about the what is P, and now we can see on the YouTube and we can understand that what is P. Okay. In interlace, I have said that in interlace we have two fields, odd fields and even field. Now some of you might have heard about the NTSC, PAL, or SECAM. Okay, what are they? NTSC is a format for work in the USA or UK. Then PAL works in the USA or UK. They have divided some category that I have this. I want this video format in this refresh rate, and otherwise they have some headers in terms of video processing. We can see the clear difference between the interlace and progressive. See the quality difference between progressive and between interlace. That's why YouTube has given progressive videos, because we can see clear difference how we can distinguish between the interlace and progressive. Interlace has much less quality than progressive. Now we come out very interesting part, how video are processed. Now we know about the what is image, what is refresh rate, what is aspect ratio, how image are built, and how image are recorded, and what is what's its criteria, and what is the aspect ratio. So now we will go through the how the video are actually processed in the very lower at very lower level, because we can directly see and see TV that episodes are recorded, but no, that is recorded in the raw format. Each raw format, if I calculate that, if raw format 1920 by 1080 by 4, then we have this much pixel, approximate 82 lakhs. But in video industry, this is the very high pixels, and we cannot We cannot give this much amount of GBs the movie to the other person. Otherwise, we will want 10 TB, approximate minimum 10 TB hard disk to deliver the one picture. Forget about the 10 or hundreds of pixels. So what actually happens in the industry, that we do the compression. We all heard about the zip is what it compresses the our data. Likewise, in video and images, in images we have JPEG or PNG. JPEG and PNG both are compressed format. What JPEG does is it's calculate the pixel, that I have the brown color, brown shadow at this level, and my neighbor pixel has also the brown color. So what it will do, that it will create the map that at the coordinate of x comma y, I have this brown color. Also at the coordinate of this pixel x dash comma y dash, I have same pixels. So it will encode, or I can say it will compress in the such a way that we have to deliver with a very less amount of GBs or MBs. So that's how compressing works. So suppose I gave the serial Tarak Mehta. Tarak Mehta is recorded, and now it is the in compressed format in video terms. Okay. So but I have to put the Sony logo, like I can show that here is the logo. Vimal is one the logo. Also the CNBC Awaz is the one logo. But how can we see that? How can we blend that pixels into our image? So here is the pipeline. So, we have IO means input output. In input, what we have one video, Tarak Mehta series, and Tarak Mehta episode number 104. Suppose in Tarak Mehta episode number 104, they have audios and videos. Also some of serial have the closed caption. We are all about the closed caption or subtitles. Forget about the closed caption now. I'm talking about the video and audio. In video, yeah, what we have to first do, that we have to first demux. What is demux? Demux is the separating audio, video, closed captions, and other header and footers data. Now going through the video data, here I have demuxed the video packet. In computer we have lots of things in the packet. So now we have to decode the image, decode the video from the packet. Now we have decoded video. Decoded video means we have the raw format. Now we have the actual 1920 by 1080 by 4 pixels. Now you may understand that why I am explaining what is the raw pixels. Now we have all the pixels. Like suppose I am giving the example of this image. This is you can see my arrow, that this is 1 pixel, this is 1 pixel, 1 pixel. Now we have control over each and every pixel after video are decoded. When the video is decoded, what we can do is we can apply simple mathematics, like this is the matrix under the understand, this is the matrix, this is the 1920 by 1080 matrix in the, or we have learned in the mathematics part. Okay. So at this coordinate x comma y, we have the pixels of this label, Vimal label. So what we can do is we can do the mathematic computation, like at the pixel of x comma y, like 6 is row number 6 and height is 3. At 6 comma 3, I have to put the pixel of Vimal rather than the CNBC hours actual image. This is same happens with Tarak Mehta or any other series. We have to compute, we have to find that at which pixel, or at which coordinate x comma y, we have to replace this pixel. Then we can easily replace these pixels. Okay, this is the terms about this is I am talking about the only for the logo. This is the one logo. Logo means it is a stable image. It is not changing in terms of the frame by frames. In CNBC, we have seen that CNBC hours number one. It is static image. It doesn't change its logo very frequently. So logo is very simple, but we have some other aspects, like what is scaling. Suppose ZTV gives us Sony Live gives us the Tarak Mehta at the 4K scale. In 4K, we have the 4 times full HD, but I have to deliver in the SD. We don't have the full HD or 4K subscription. Then what we will do? We cannot give the full HD or 4K videos to the client. So what we do? We do this scaling. What scaling does, it reduces the height and width such a way that it doesn't lose its quality. It is called scaling. What is the interlacing? The interlacing is nothing but scaling, but in terms about the, it is separating or decoding the video. What is denoising? We have some noise, white and salt and paper noise. Like in my header, video processing end to end by, I have added salt and paper noise. You can see that it is the salt and paper noise. But this noise we have to remove from the image. So it is the one part of denoising. Then blur. In our mobile, what we'll do is we blur our background. We just put our face or our body at the front and side, but our background is blurred. It is the same. What is sharpen? Sharpen is like sharpening the border. Now in some videos, in some images, we have seen that, yeah, borders are not that sharp, or borders are not that great looking, so that we cannot deliver to the client. So what we need to do, we need to find the age. In image processing, we have some age detection algorithm. From age detection algorithm, we find the age. Then what we will do, we will add some extra pixels to sharpen the image. After all the graphics processing, what we need to do, we need to recompress that. Otherwise we cannot deliver to the channels. So we need to again do the encoding, video encoding, or we can say the video compressing, like we are doing in the zip format. Now I'm talking about the audio, same audio decoder. It is same, comes from the demuxer packet, audio packet. We need to first do the audio decoding. Now we have the each and every audio decoded pixels, or audio decoded frames, I can say, in terms of frames. Now we have to do is, we have to convert one audio container from the another audio container. You might have seen about the container like in AC3 or AAC. Some are you might heard about that or might not, but it is the compression format. We have to convert one format to the another format, or resampling. We all have heard about that. What is the rate at which audio is delivered? Sometimes we have 44 kilohertz, or sometimes we have 16 kilohertz, sometimes we have 48 kilohertz. But the TV channel or some GTPL or DAN, they want us to give at only 48 kilohertz or only 44 kilohertz. So what we need to do, we need to resample the audio into its desired format or its desired level, so that we can deliver. Then after each and every audio row frame is processed, then we need to re-encode it. So we are doing re-encoding. Now we have encoded video and encoded audio. So what we need to do, we need to combine all the audio, all the video with its closed caption and some headers. Now we have here we have 10 TB movie. Here we have, after this machine, here we have only 1 GB or 2 GB movie. Now 10 TB is converted to the directly to the 1 GB. This is the magic of the encoder packet and muxer packet. If we deliver this part only, raw audio and raw video, then we need to deliver 10 TB movie. We cannot even transfer to our friends that look, see this movie. Okay. Now you have seen this audio encoder and video encoder. And further going into deep, that what is audio encoding, what is video encoding. Audio encoding is not the topic today. It is our topic today is the video encoding. So I'm going to the deep into the video encoding. In live video encoding is the process of compressing large raw video and audio files so that they use less network bandwidth. I have said that if you have to give movie, or you have to upload movie on the uTorrent or on the Netflix, then we have to upload the 10 TB movie. rather than 1 GB movie. So what we need to do is we need to encode it or compress it, so we can easily upload that movie on any platform. When working with video files rather than live video, encoders are used to compress and reduce the size of the video content so that it can take up less storage space and be easier to transfer from one part of a video production workflow to the another. To achieve these levels of compression, video encoders use the video compression algorithms known as codecs H.264, H.265, or any other MPEG codec. I'm showing one uh, my DAN or the GTPL setup box provider. We have setup box attached with the TV. And setup box, you have seen about these labels, what the HD, PVR, DV3, H.264, HDMI, but you don't know what is this. You only know the what is HDMI. HDMI we use with the laptop to connect laptop with them with our TV, but you don't know about what is 1080i. Like, see, you can see the 1080i. What is 1080i? What is I is interlace. We have seen this in this movie. This is interlace, and this is progressive. So on my Dan broadband, I have 1080i. I am receiving 1080i HD movie if I subscribe for the HD. If I go with the DV3, DV3 is what? It's a digital video broadcasting. It's broadcasting like it is broadcasting the Tarak Mehta or Pavitra Rishta or any other Crime Patrol or any other series. And now this is the H.264. H.264. Here it is the here I have term called the H.264 or AVC or H.265. What is H.264? H.264 is an algorithm for the compressing the video. We might heard about the Huffman encoding. Some of you might have heard about the Huffman encoding. Huffman encoding is for the compressing the binary data or text data or some digits. But for the video, we have H.264 and H.265. This is nothing but the H.264. So what my broadband want only H.264 video to be broadcasted. So what ZTV needs to do, ZTV needs to give us the format in the H.264. So at this level, encoder level, video encoder level, we need to transform from one video to the H.264. Then only we can see on the our broadband. So that's why. And HDMI we know. Now I hope you know about your broadband, and you can see on your setup box that at which quality and for which encoding algorithm are used for the video. In video decoding, this is the video decoding part. In video decoding is the process of decoding or uncompressing, like unzipping the file. Same as in video, we call this decoding. A video decoder converts an encoded video stream. Like here we have mux the packet. Mux package are encoded packet, means compressed packet. We need to decompress it. This is all it said, so that we can broadcast into production system. Okay. See, how different algorithm like Huffman and other like Huffman with compared to Huffman. Suppose I have XYZ algorithm, how it can save our bandwidth.
Excuse me, sir.
Yes. Okay.
Excuse me, sir.
Yes, sir.
I
Yes, ma'am.
think there is a network issue, so your voice is breaking.
Okay. Hello. Now you can hear the problem.
You can do one thing. You can off your video so
Okay.
that
Okay. If this persists, then again told me that, and then I will change my broadband. Now, how is the quality?
it's better, sir.
Okay. Okay. We are talking about the how encoding how encoding change the game. Like in H.264, suppose our broadband, then broadband or GTPL broadband have to deliver at the 32 Mbps speed for the 4K. If we just change one algorithm from H.264 to H.265, then it compress our video by 50% or more. We can say more than 50% it compressed our video. So what our broadband needs to do, just it need to broadcast at the just speed of 15 mbps rather than the 32 mbps. So it is the game changing scenario. Like from day to day we are now we are finding, or some R&D department are finding some new encoding algorithm, so that at much lower speed or at much lower bandwidth we can deliver high quality and less bandwidth utilize the video. Now talking about the graphics, at this stage I need to add some graphics like logo or some other. I'm talking about the which types of graphics we are here at which at this stage we have raw pixels. Okay, on raw pixels we can do anything, so we need to blend our graphics at this level. So what types of graphics we have? Some 5 to 10 types of graphics. I'm describing some of these graphics: logo, alert, L squeeze, animated logo, and scroll bar. So we all have seen about the logo. CNBC Avaz is one logo. Then this is the Vimal sticker. It is a sticker, it is the same as logo. It has the same logic as this CNBC Avaz logo. What is alert? This is an alert. We have seen some alert a message like fire emergency or some or on our broadband we have seen this digit one dash 800. It is nothing but an alert. So what is L squeeze? L squeeze, we have seen that see this corner. So you can remember that in some channels we saw this type of advertisement, like this pops up for 1 minute, then this pops down after 1 minute. So this is the L squeeze. I will talk about how it algorithm works. L squeeze. Then what is animated logo? We have seen about the round logo, like in logo as after 1 minute it's just doing animations. That is the animation logo. On scroll bar, this is the scroll bar. Suppose we might you might go went through this channel CNBC Avaz or some channel, this adds some display that. So take an example of the ESPN channel. If there is a rain, then it has a scroll bar that match is delayed due to the rain. That is nothing but a scroll bar. So now logo, we learn about the logic that I have to go through the pixel at the x comma y coordinate to the x dash comma y dash coordinate, and I have to replace each and every pixels. For alert, we have we have to find at which width and at which height we need to put an alert. But we put a square box first. It is done by some library, or we can do manually at this at the from x comma y to x dash comma y dash. We need to put the white color. White color is nothing but 255 255 255. Okay, and at these pixels after this much width I have to write f. So at internally what we need, if we are writing our own library rather than using some third party library, so at this pixel of f we have to put the red color. If the red color have a red color has the value 255 comma 0 comma 0 is nothing but RGB. R20 R255 means full red, and green is 0, and blue is 0. So we need to put this value 255 comma 0 comma 0 at this x1 comma y1, then x2 comma y2 x3 comma y3. Likewise we need to find each and every pixel, and we have to put each and every value like in green color or in blue color or any color. We have to use this. Now I'm going through the L squeeze. How L squeeze works? In L squeeze we have this image, but we cannot show this image directly. What we need to do is we need to do the 1 minute animation. 1 minute is 60 seconds. So in 60 seconds, we have to 60 seconds, 60 seconds, in 1 second we have seen the fps in 25 frames. So 25 into 60, that much frames we have to process to just display these graphics like LSPs. We have seen this arrow tag, left hand side arrow tag and bottom side arrow tag. So what we need to do is we need to divide our 1 minute logic divide by 60. So suppose this is the width x comma y. So we need to divide x comma y by 60 by 60. So at the time of starting the L squeeze, we are here. Then we need to decrease x and decrease y. X by 16 and y by 16. Again we need to decrease x comma y. Again x by 60 up to we will reach to here. This make the 1 minute animation. Then after 1 minute we need to plus the x comma y coordinate, at x comma y, this x comma y, so x plus x by 16 and y plus y by 16. That's how this animation are calculated, and we know the pixel level calculation. What we need to do, we need to find these coordinates and we need to replace this advertisement file with our original video file. In animated logos we have, suppose we have animation of 15 seconds, and in 15 second how much frame we have? 15 into 25 if we have the 25 fps video. So we need to process 15 into 25 frames for just of doing the one animation. So we need to divide our calculation divide by 25, suppose 15 seconds, then we need to divide by the 15. For 1 second we have x by 15 and y by 15. After that we need to plus that x by 15 and y by 15. That's how we can make the animated logo. Now we have talked about the how it works, but what is the challenge in this? When I joined my company, we are delivering full HD videos 1920 by 1080, but people are demanding nowadays for 4K videos, and sometimes people are demanding for the 8K videos. But our computer and our latest computer are now capable to do the processing at that much higher level, but they are not automatic. We need to think about that, or developer need to think about that, how we need to calculate this much pixels, 4 times HD pixels at the same time. So we can do the some same calculation, like if we have 25 frames per second. So, okay, so in 1 second we have 25 frames. Okay, so suppose in 1000 millisecond, means 1 second divide by 25. So we have only 40 milliseconds to process each frame. But for HD 40 millisecond, you can think in terms of 40 milliseconds is like nothing. In 40 milliseconds we have to process this much pixels, but 4K we have to process in 40 seconds, 4 times faster than the full HD. Now it is the trouble for the developers and any video industry, and how to achieve and how to survive for that, how to survive the demanding. We have the demand in 4K videos, but we need to deliver the 4K videos. Then how to do the calculation? Then comes the some smarter approach. Smarter approach, like we have some threads. If you are coming from the computer engineering background or IT background, then you might heard about the thread and parallel processing. Suppose I can show you my processor. So I have this much processor. 4 by 3 means 12 processor. So now I can calculate only 12, only 12 process parallelly. More than 12 I cannot process that at h time t. Okay, but rather than processing at a single processor, we I have 6 processor and 12 threads. Rather than using only single core, I can utilize 12 cores or 12 logical processor or 12 threads. So on in smart approach, what we are doing is, we are using some threading approach. In threading, what we do is thread you we all use thread, but we don't use at a very higher level. At higher level, what we do is we are using thread pools. In thread pools, we are spawning 40 to 50 threads all before starting processing any videos or audios. Now we have 40 threads parallel running which are waiting for some task. Here we have the queue. If we are buying some movie ticket from the theater, then at the box we have the queue. This is same as the task queue. We have lots of tasks on the computer to do. So what we are doing, we are queuing our each and every processing in the task queue, and we have 40 threads ready to process it. So uh, I have 12 core. Out of 40, at time is equal to t, I can process 12 tasks parallelly. So now you can understand that how to achieve this much higher level of pixel complexity in very smart approach. This is the thread pool. This is the thread pool. Here task comes. It sees that if this thread is free, then it can process on any of the logical thread. Then after completion of the task, we can pass to the next pipeline. Suppose first pipeline we have logo, in second pipeline we have l squeeze, in third pipeline we have alert. So after doing logo processing, we are passing that image to the l squeeze, then we are passing that image to alert. Okay, and now we have memory pool. We all heard about that I have 8 GB RAM or 16 GB RAM, but how to utilize that memory? Suppose in 40 millisecond I have to do 4 times faster memory processing, memory as well as complexity processing. So here I have 16 GB RAM. Okay, so I can utilize all the available GBs to process that. What I will do is I will take, or I will allocate the as much amount of memory as much I can before starting any video processing. Now you can think about that, how it will help. If we have already allocated memories, then we don't need to go to the CPU and ask for the available memory, that give this much memory. If CPU gives 4 MB memory after 2 milliseconds, then we are wasting our 2 milliseconds at the time of video processing. So rather than asking our CPU to allocate a memory, what we are doing is we are allocating before we start doing any video processing. This will save huge amount of time. This is one type of optimization. But here comes the scenario that we have only 12 cores, but we have 1920 by 1080 by 4, this much pixels. This is not capable to do that much amount of processing at the level of 4K. So what nowadays we are doing is we are using GPU. We all have NVIDIA GPU or AMD processor or AMD GPU. What is GPU and what is CPU? CPU, all about that. We have Intel CPU or Intel i3, i5, i7, or some of you have Ryzen, AMD Ryzen CPU. Okay, what CPU has? CPU has 6 cores. Like you can see, the here is the 12 cores, here is the 6 cores. But in the GPU is a graphics processor memory. We have NVIDIA GPU. We are using NVIDIA GPU as much as we can rather than using AMD GPU. In GPU, what we have is we have these thousands of cores rather than only 6 cores. You think about that, I have i7 processor, but rather than using this only 12 cores, I have thousands of cores. So what we can do is we can calculate each and every pixels at the thousands levels of parallel. Now you can think about that, rather than only using 40 threads, I have thousands of threads which can do parallel processing. This is the magic of this GPU. So we are preferring GPU over CPU when we have to do the pixel calculation or this much amount of calculations. Okay, now we all went through the we all 95% we all went through the matrix multiplication. Okay, in the maths, in 11 12 or in college life, we have seen about the matrix multiplication. So how we can achieve matrix multiplication at very fast level. Suppose you are thinking about some mathematics department guys thinking about that how much scientists or some data scientists process this much amount of matrix multiplication at a very higher speed. Then this is the magic that I'm going to explaining. That suppose in matrix multiplication we have matrix 2 by 4 matrix and 4 by 3 matrix. So after this row and this column we have C11, and after this row this column we have C12. Likewise we have C21, C22, C23. But one thing we need to observe that C11 has nothing to do with C12, and C12 nothing to do with C13. Likewise C21 nothing to do with any of its neighbors. So what we can do at the computer level, we can process each and every C11, C12, C13 parallelly, because C11, C12, C23, any of them are not dependent of any of its neighbor. So we have this much thousands of cores available. So what we can do is we can do all the parallel multiplication and addition processing at each available course. So you can think about that we have the 1920 by 1080 by 4 pixel multiplication we can do easily with a matrix multiplication. Now I'm talking about the game. In game we all game or in deep learning, machine learning or artificial intelligence. Artificial intelligence is nothing but a game of maths. In artificial intelligence there is a department of deep learning. Deep learning is nothing but a matrix multiplication. If you know about the matrix multiplication, then you can be the master of the artificial intelligence. Artificial intelligence is nothing but the algorithm combination of different algorithm for the matrix multiplication. In machine learning or deep learning, what we are doing is we are calculating all the parallel complexity, all the parallel algorithms with this magic of matrix multiplication independence. May I confirm that I am audible properly?
Yes, sir, you are audible,
Okay.
and we have 10 minutes left. So you
Okay.
can conclude the session after 5 minutes.
Okay. So now we heard about the matrix multiplication, this much level of parallel. Here are some comparison between GPU and CPU. In GPU, we are doing optimized parallel operation. Here for CPU, we have serial, means one task by another task. One give one ticket to one person, then give another ticket to another person. And low latency in image pipeline is the high latency. Latency means what? The processing time. If we have less processing time, then we can display more frames. We have in first we see that we have 60 fps or 30 fps, 25 fps. That is nothing but the latency for this image. So here is the difference between CPU, GPU. In TPU is the tensor processing unit. It has some another algorithm, but it is works same as the GPU. Okay. Now comes about the WhatsApp video calling. It is very interesting. Suppose we are doing WhatsApp video calling, or we are broadcasting on the Google Meet or FB Live. Then how two machines sends data between each other? Then we have some protocols in computer, TCP or UDP. TCP is nothing but transmission control protocol, and UDP is nothing but the user datagram protocol. TCP has some mechanism to communicate between two PCs. So what they are doing is they are passing the IP address to each other, and then they are doing the handshaking. Okay, we are friend, and now we can transmit the packet. What is packet? Packet, we have seen that earlier we have seen that we have this packet, mux the packet and demux the packet. This is the packet. Okay. And from TCP we are using we are from using internet. We can send data between one host to the another host, or we can say one peer to the another peer. In TCP we have benefit that if our internet lost or if our packet drop, then we can retransmit the packet to the other peer. But while in terms of UDP, we cannot transfer our missing packet. So when we are watching any YouTube videos or any serial like Tarak Mehta. If we missed one packet, then we cannot retrieve some another packet. We are transmitting our audio and video in UDP protocol, using UDP protocol. So suppose we left only 2 frames. If we have 25 fps, if we lost 2 frames, then we got 23 fps, but it is okay for us. If we lost 2 frames, then it is okay. We do not need to see that frame after 1 minute. So that's how TCP and UDP works. In TCP, what we do, we client one sends the request to the server that I have to do the connection. Then server send yes, yes, acknowledgement. I got your packet to request for request. Then I send the acknowledgement. So we are now friends. We can send the packets. uh, on using here is the Zoom or any other WhatsApp system design I'm going to talk about, but due to some time limitation we cannot go through this terms, but we can no, we have a lot more slides, so we can not go through each and every detail. So now I can rapid this session. Otherwise, we need to dig deep into this to understand how WhatsApp works and how Zoom works. Okay. If some of your faculty have any questions or any difficulties, then we can discuss
Oh,
that.
okay, sir. Anyone have any questions? Actually, sir, some of might be joined through PU webinar on Facebook.
Okay.
So right now there is no question. And thank you very much, sir, to give us the idea about how matrix multiplication is used, what is the use of matrices in the computer engineering, and what students can do with the matrix multiplication. Uh, so thank you very much, sir. And again, I want to say thank you to give your time and to give us the understanding about video processing.
Okay. Thank you. Thank you. Thank you all the board members and all the faculties. If any of you have any doubts or any questions, then you can again ask me, or you can contact me personally.
You can leave your mail ID, sir. Here.
Okay. My mail ID, you can note that. My mail ID is gjaimit74@gmail.com.
See you webinar. See you webinar. Okay, sir. We can stop here. Thank you, sir.
Okay.
You
Okay.
can leave.
Thank you. Thank you all.